Have you ever just looked at a simple pill and really thought about what's inside? I mean, it's this tiny, everyday object, but it is packed with an incredible amount of engineering and precision science. It all starts as a simple powder and ends up as this perfect, uniform dose. Today, we're going to pull back the curtain on that amazing transformation.
All right, so here's our game plan. We're going to start with the basic anatomy of how a tablet is made. Then we'll walk through the two big stages. First, compression, which is where the tablet is actually formed, and then coating, where it gets its crucial final finish. We'll even do a deep dive into the modern machinery before we wrap up with the super important step, quality control.
So let's kick things off right at the beginning. We're going to trace the entire path of this thing from a pile of powder to a finished, ready-to-go product.
I mean, that's really the big question, isn't it? It kind of seems like magic, but it's not. It's actually a masterpiece of mechanical engineering and pharmaceutical science all working together in perfect harmony.
So this right here, this is the whole journey. You can see it starts with planning and getting materials, then moves to dispensing, blending, and granulation. But for our purposes, we're going to zoom way in on the two most intense and, frankly, the coolest steps. Compression, where the pill is born, and coating, where it gets its final identity.
First up is compression. You can think of this as the brute force stage. This is where we take a loose blend of ingredients and forge it under enormous pressure into what's called a tablet core.
Let's get a really clear definition here. So compression is a mechanical process. It takes a powder, which is a mix of the active pharmaceutical ingredient, the API, that's the actual medicine, and other things called excipients that help it all stick together. And it compacts that powder into a solid tablet with a very, very specific size, shape, and weight every single time.
So how does this actually happen? Well, it all goes down inside a machine called a tablet press. At the top, you've got the hopper, which just holds all the powder. The feeder moves that powder into the dies. Think of these like little molds that give the tablet its shape. The real heavy lifting is done by the punches, which come together to press the powder inside those dies. And the conductor of this whole orchestra? That's the cams, which are these tracks that guide every movement with unbelievable precision.
The whole thing is this beautifully synchronized three-step cycle. First is filling. The bottom punch drops down, creating a little cavity, and the feeder swoops in to fill it with powder. Second, compression. The top punch comes slamming down, squeezing that powder with an exact amount of force. And finally, number 3, ejection. The top punch pulls back, and the bottom punch pushes the brand new solid tablet up and out of the die. This cycle just repeats, thousands and thousands of times a minute.
In the speed, it's just mind-boggling. A modern rotary tablet press can churn out over 1 million tablets an hour. Just think about that for a second. That's almost 300 tablets being created, compressed, and ejected every single second. Incredible!
Okay, so now we have our compressed tablet core. But we're not done yet. It's time for stage 2, coating. This is where the tablet gets its final, protective, and often functional outer layer. And trust me, it's way more than just a pretty paint job.
So why even bother coating tablets? Well, there are a bunch of reasons. Of course, there's aesthetics and branding. That specific color helps you recognize your medication. It's also absolutely crucial for masking a bad taste or smell, but it gets more technical. The coating can control how and when the drug is released in your body. A special enteric coating, for example, protects the drug from your stomach acid, so it only dissolves later on. You can even add a second medicine in the coating itself, or just make the tablet smoother and way easier to swallow.
What's really fascinating is how the technology has evolved. The old-school method, sugar coating, was basically an art form. It was slow, it was manual, it could take days, and it added a ton of weight to the tablet. The modern method, on the right, is film coating, and it's a total game changer. It's a fast, automated process where a super thin polymer film is continuously sprayed on, adding almost no weight and giving you perfect, repeatable results every single time.
So let's talk about the machine that makes all this modern film coating possible. This is not just some simple spinning drum. It is a seriously high-tech piece of equipment engineered for maximum efficiency.
And this is a perfect illustration of cause and effect in engineering design. The cause, the need to process tablets faster. The mechanism, well, they literally stretched the coating pan out so they could fit more spray guns inside. And the consequence of that? The stretch design allows for way higher spray rates, which dramatically shortens the time it takes to process an entire batch. It's brilliant.
Now, if we zoom in, we can see the real heart of the system, the manifold spray bar. The key innovation here is that all of the lines, for the solution, for the air, are tucked away inside the bar itself.
That, plus a simple one-gasket design, makes it incredibly fast to clean and reconfigure. And in a pharmaceutical plant where speed and sterility are everything, that is a massive advantage.
Airflow is absolutely critical for drying the coating as it's being sprayed on, and there are two main designs you'll see. On the left, you've got the fully perforated pan. Air flows right through the bed of tablets, which is great for super efficient drying and perfect when you're working with potent compounds. On the right is the integrated plenum design. This one's better for solvent-based coatings because it works really well even with lower air volumes.
All right, so we've got compression down, we've got coating down, but you know what? None of this high-speed manufacturing means a thing if the final product isn't absolutely perfect. And that's where rigorous process control and nonstop testing come into play.
So the most important thing to understand is that every single variable is being monitored and controlled. During compression, the depth the dye is filled to directly controls the tablet's weight, making sure the dose is right. The compaction force determines its hardness, which affects our dissolves later. Then, during coating, the speed of the pan makes sure every tablet gets coated evenly, while the spray rate and the air temperature have to be in perfect balance for the coating to dry properly. Each parameter is like a lever that has to be pulled with absolute precision.
And all throughout the manufacturing run, samples are constantly being pulled for at-line testing. I mean, they check everything. You've got physical properties like weight, hardness, and friability, which is just a fancy word for how well it resists chipping. And then you have the chemical properties, like the assay, to confirm the amount of active ingredient is exact, and dissolution, to make sure the drug releases from the tablet at precisely the right rate.
And finally, you've got some extra equipment that acts as a final quality check. Every single tablet has to pass through a metal checker to catch any possible contaminants. Then, a de-duster gently tumbles the tablets to remove any fine powder residue. This just ensures a clean, perfect finish right before they go into the bottle.
So, from a simple loose powder to a perfectly coated pill, it's a journey of incredible mechanical and chemical precision. It really makes you wonder, doesn't it? What other everyday objects that you see are hiding a whole world of complex science and brilliant engineering just waiting to be explained?